So we have one here from MIT 2022, regular season number 3. And it's pretty complicated with all these inverse trig functions going on. I was thinking there's a lot of different ways to do this one, but there's different decision points. It's like a choose your own adventure where you could probably do it like 8 different ways. But let's just focus on this for starters. And also the bounds. I really wanted to clean this up because it's kind of ugly to look at. So what we could do is a U-substitution, adjusting this to get it around 0. The way we can do it is with u equal to pi over 2 minus x, and then of course we can rearrange that to be also x equals pi over 2 minus u for our substitution. And when we take a derivative, we're going to have dx is going to be minus du. So when you do this, what's going to happen to the bounds is we're going to end up this thing, plug it in there, it's going to become a minus 1. This one down here, same kind of thing, it's going to be a plus 1. Now we're symmetric around 0. And then, you know what, to kind of save a step here, we don't really need to rewrite the whole thing. But what we're really interested in is plugging into sine. So if we plug in for x here, we're going to look at sine of pi over 2 minus u. That's just the complementary angle formula. So that's going to be cosine u. So now let me take this and plug it in. We could kind of save a step, but I want to show it clearly. So we have arc sine, here we have arc cosine, and then here it's going to be cosine of u. And then let's plug in for our dx, that's going to be minus du, but I can use the minus sign here to flip the bounds around. So then we can get the positive up top, the minus at the bottom. And now with it symmetric around 0, what we can do is get rid of that junk right there. But no, really what we need to do is symmetric around 0, even function. Because if you plug like minus u in here, the cosine's an even function. So then we can use that principle there to change this to a 0 and bring a 2 out front. The reason I wanted to do that before going forward is because right here, our cosine of cosine, this is going to be the same thing of u, but only for cosine u. So technically we had to do this first. It wouldn't really matter, you could do it in a different order, but to make it kind of obvious, I did this first in order so that we can say that this here is going to just be a u. And now continuing to work from the inside out, let's deal with this arc sine of u right here. So for this, let's do a quick label and we'll call this y. So then if you rearrange that, just taking sine on both sides, we can say that u is going to be the same thing as sine of y. What this will allow us to do, you could do it without this, you kind of just do it using the Pythagorean identity, but let's do the triangle instead. Or also, this always works out the same, but the angle on it's going to be y, and then we're saying sine of y is u, so we can look at that like u over 1. So we can create our triangle, let's do a better u though, we can create the triangle like this. And then the third side with the Pythagorean theorem is going to be 1 minus u squared. So in our integral, what we have is cosine of y. Cosine is going to be adjacent over hypotenuse. So we can say cosine of y is going to be just this thing right here where the 1 doesn't really matter. So we'll do a quick rewrite again. And now our integral is just going to be this thing, 1 minus u squared du. This is what I meant by a bunch of different choices, because you had a choice of how you wanted to do this. There's a choice you didn't need the triangle, you could do that a different way, and then there's a choice here. The way I like to do this, I'll stay with it, is thinking about this as a circle, because if you rearrange it and think of this like a y, it's going to be, squaring both sides, it's going to be something like this. So you end up with a unit circle with this, right? If this is 1 squared and that's the radius, this thing is going to be like a unit circle, pretty rough. And the area of a unit circle, pi r squared, where r is 1, the whole area is just going to be pi, but we've got some restrictions on it. Our bounds are from 0 to 1. So like we only want, let's do this, we only want from, if this is 0 and this is 1 right here with the radius 1, we only want this side. But in reality, the square root never returns the negative values. This is always greater than 0. And so we don't worry about this fourth quadrant. We're only worried about a first quadrant. So we just want 1/4 of the circle. So this area right here is pi over 4. So to finish it, we just plug in, but we've got 2 in front. So the solution 2 times pi over 4, multiply it out, and what we have is just pi over 2, and that's it. All right, there you go. Good one from MIT 2022. Thanks everyone for watching. Have a good day.